Welcome to G Fun Facts Online. In the vast, dark expanse of space, we often expect celestial events to follow predictable scripts written by the laws of physics. Planets orbit, stars burn, and comets, for the most part, behave as we expect. But every now and then, the cosmos throws a curveball, presenting a spectacle so unexpected it rewrites our understanding. Today, we're talking about one such cosmic rebel, a comet that was sentenced to death, but came back transfigured, cloaked in gold. This is the story of Comet C/2025 K1, also known as Atlas, the Golden Comet. Our story begins not with a bang, but with a barely perceptible whisper of light. In May of 2025, a network of robotic telescopes collectively known as the Asteroid Terrestrial Impact Last Alert System, or ATLAS, picked up something new. Spread across Hawaii, Chile, and South Africa, the ATLAS system is our planet's tireless night watch, constantly scanning the sky for any object moving on a potential collision course with Earth. Most of its discoveries are faint asteroids, unremarkable dots of light on a long exposure image. And at first, that's all C/2025 K1 seemed to be. It was logged as a 19th magnitude object, which is incredibly faint. For perspective, the dimmest stars you can see with your naked eye on a perfectly dark night are about 6th magnitude. A 19th magnitude object is over 150,000 times fainter than that. It was just another blip in the constellation Pegasus. Soon, however, follow-up observations revealed a telltale sign, a faint, fuzzy atmosphere, or coma, surrounding the object. This wasn't a solid rocky asteroid. It was a comet, a dirty snowball of ice and rock beginning to warm up as it approached the sun. But even then, Comet Atlas didn't exactly make headlines. It was actually the third green-hued comet, discovered by the survey that year. And it was by far the dimmest of the trio. The astronomical world's attention was captured by a much more glamorous object. Another comet found by the same survey named 3I/Atlas, which was an interstellar visitor, a messenger from an entirely different star system. So C/2025 K1, our future golden comet, was initially the wallflower at the cosmic dance, overshadowed and largely ignored. But astronomers were about to discover that this comet had a truly extraordinary story to tell. By plotting its trajectory, they realized something profound. This wasn't just any comet looping around the sun. C/2025 K1 was what's called a dynamically new comet. This means it was making its very first, inaugural journey into the inner solar system. For billions of years, it had been in a cosmic deep freeze, orbiting at the furthest, coldest fringes of our solar system in a region known as the Oort cloud. The Oort cloud is less a place and more a concept, a vast spherical shell of trillions of icy bodies thought to encircle our solar system like a ghostly bubble. It's the solar system's attic, a repository of leftover material from the primordial nebula that formed our sun and planets 4.5 billion years ago. Comets from the Oort cloud are pristine time capsules. They are completely unaltered, holding the original chemical recipe of our cosmic neighborhood. Studying them is like finding a perfectly preserved fossil of the solar system's birth. But being a dynamically new comet also came with a death sentence. Its path was charted, and the forecast was grim. The comet's trajectory was taking it on a kamikaze run, perilously close to the Sun. This closest point in its orbit, known as perihelion, was scheduled for October 8, 2025. And when we say close, we mean uncomfortably close. It was set to skim past our star at a distance of just 31 million miles, or about 49 to 50 million kilometers. To put that into perspective, that's less than a third of the distance between the Earth and the Sun. At that range, a comet faces an onslaught of unimaginable forces. First, there's the Sun's immense gravity. The gravitational pull is so intense and varies so much across the comet's fragile body that it creates powerful tidal forces, trying to rip the comet apart from the inside out. Imagine being stretched and squeezed by an invisible cosmic giant. Then there's the radiation. The comet would be blasted by ferocious solar winds in a torrent of ultraviolet radiation, a celestial blowtorch that would vaporize its ices at an explosive rate. For a first-time visitor from the cold, dark Oort cloud, this trial by fire is often fatal. The thermal and gravitational shock is simply too much. Many experts, looking at the data, predicted C/2025 K1 would disintegrate. They expected it to break apart completely, its ice and rock scattering into a diffuse, unobservable cloud of cosmic dust. It would be a silent, fiery death, and the comet that was barely noticed would be forgotten forever. October 8th came and went. The comet swung behind the sun, hidden from our view by the star's blinding glare. For 10 days, the astronomical community waited. Did it survive? On October 18th, telescopes were once again pointed at the spot where the comet was predicted to re-emerge. And there it was. Not only had C/2025 K1 survived its fiery ordeal, but it had been utterly transformed. It was a phoenix, reborn from the solar fire. Before its close encounter with the sun, the comet had glowed with a familiar, ghostly green light. This is a very common color for comets. The green hue comes from a molecule called diatomic carbon, or C2. It's essentially two carbon atoms bonded together. When the sun's ultraviolet radiation hits this molecule in the comet's gassy coma, it causes it to fluoresce, to glow with that characteristic emerald light. But the comet that emerged from behind the sun wasn't green anymore. Observers were astonished to see that it was now painting a stunning, rare, and brilliant golden streak across the sky. So what happened? Why the dramatic color change? The secret to its transformation wasn't something that happened at perihelion, but something that was part of its identity all along. The clue lay in observations made months earlier. Back in August 2025, before anyone knew it would be a survivor, astronomers at the Lowell Observatory in Arizona conducted spectroscopic observations of the comet. Spectroscopy is a powerful tool that allows scientists to analyze the light from a celestial object and determine its chemical composition, like a cosmic fingerprint. The results were bizarre. The spectrum of C/2025 K1 revealed that its coma was severely depleted in carbon chain molecules. Specifically, it was lacking in the very diatomic carbon C2 that makes other comets glow green. It was also deficient in another common cometary molecule, cyanide or CN. This was a huge surprise. This particular chemical signature is exceptionally rare. In the entire history of cometary observation, only 2 other comets are known to have such a strikingly carbon-poor composition. Comet C, 1988 Y1, known as Janaka, and the more famous periodic comet 96P Maholtz. C/2025 K1 was now the 3rd member of this exclusive and chemically weird club. This pre-existing condition, its lack of carbon, is the key to its golden transformation. With very little diatomic carbon to produce a green glow, another effect was able to take center stage. When the comet rounded the sun, the intense heat didn't just melt its ices, it blasted away a colossal amount of dust from its surface. The comet essentially shed a significant portion of its outer layers. Now, as it moves away from the sun, the solar wind, that constant stream of charged particles flowing from our star, is catching this massive cloud of dust and blowing it out behind the comet. This forms a long, spectacular tail, and this tail isn't glowing on its own, it's simply reflecting sunlight. The dust particles act like a vast, celestial mirror. And just like how dust in our own atmosphere can make a sunset appear red or golden by scattering sunlight, the dust in the comet's tail reflects sunlight in a way that gives it this magnificent golden hue. The typical green from carbon was never strong to begin with. and now it's completely overwhelmed by the brilliant golden light reflected by a truly enormous quantity of dust released during its death-defying solar passage. This makes Comet Atlas more than just a pretty sight. It's a scientific treasure trove. Its very existence and unique composition challenge our models of the early solar system. The Oort cloud was thought to be a relatively homogeneous mixture of primordial ices, but a carbon-poor comet like this suggests there might have been distinct chemical zones or variations in the primordial nebula from which the planets formed. Perhaps C/2025 K1 formed in a region of the early solar system that was naturally deficient in carbon, or maybe some unknown process stripped it of carbon later on. Whatever the reason, it tells us that the family of comets is more diverse and has more stories to tell than we previously understood. Furthermore, its incredible resilience is a lesson in cometary physics. Why did it survive when so many others are destroyed? What is the nature of the